We need to talk about scientific notation. And scientific notation is a way to express very large or very small numbers as something shorter and easier. You just make it a number times some power of 10. So the concept is basically that one number can always be written as a product of two other numbers. For example, 6 can be written as 3 times 2. 210 could be written as 21 times 10. Or 2000 could be written as 2 times 1,000. So any number can always be written as a product of two other numbers, and that becomes handy when you need to write extremely large numbers or extremely small numbers, such as these two. And this is just a quick example of scientific notation. This extremely large number, which I'm not even going to try to pronounce, could be written as 6.2 times 10 to the 15th power. That is an example of scientific notation, and I'll explain the different parts of it and make sure you understand how to do it in just a second. Here's a very small number, which I also will not try to pronounce what that number is, but this number could be written as 5.340 times 10 to the negative 10th power. And these two are examples of scientific notation. This is not an example of scientific notation, and neither are these. These two numbers represent multiplied factors that are equal to these other two large and small numbers that we have over here. And that's why scientific notation is helpful, because it lets you shorten up very large or very small numbers, and it also helps you to eliminate unnecessary zeros that are not significant. So we've talked about significant figures already, so we'll just move on. Scientific notation parts are important to understand. And so first, there's always going to be just one digit in front of the decimal when you have proper scientific notation. All the other digits that are significant, and we only use significant figures, all the other significant digits are going to come after the decimal. And you'll notice in the example from before, there's only one number in front of the decimal, and all the other numbers that are significant come after the decimal. And you should be asking yourself, what about that 0 right there? Hopefully you remember your 0 rules from the significant figures lesson. Only significant figures are shown, and the power of 10 times the significant figures gets you back to your original number. So here, if I multiply 6.2 times 10 to the 15th power, that will get me back to my original number. It's like multiplying 6.2 times 10 times 10 times 10 times 10 times 10 15 times. Or if you take 5.340 times 10 to the negative 10th power, it's like dividing this number by 10, by 10, by 10, by 10, by 10, by 10, 10 times. So times 10 to the negative power is like dividing by 10. Times 10 to the positive power is like multiplying times 10. So let's try these two examples real quick, and I'll show you how to do this. 234,200. The first thing we need to ask ourselves is, what are the significant figures here? Are these two zeros significant? The answer is no. So the only significant figures here are these four. So when we write our significant figures out in scientific notation, we're going to write 2.342. Now, that's the first part of my scientific notation. One digit in front of the decimal, all the other digits that are significant after the decimal. Now I need a times 10 that will get me back my original number. So what times 10 amount could I multiply times this 2.342 to get me back to my original number? Well, if you look at this, here's where my decimal place started out at the end of this. I had to write the decimal place in because it wasn't written originally, and these zeros are placeholders letting me know that this number was in the hundreds of thousands. So that decimal place is going to have to move 1, 2, 3, and then 2 more places to get me back to my original decimal place. So this power of 10 is going to be 10 to the 5th power. So if I had my decimal here, it would have to move 1, 2, 3, 4, 5 places to get back to its original spot. So that means my scientific notation is 2.342 times 10 to the 5th power to represent this number. What about this one? Are these zeros significant? No. Zeros to the left are not significant. How about this zero on the end? Is it significant? Yes, because the decimal is shown in the original number. So here are my significant figures in this number. There are 4 significant figures. So I need to show all 4 of those, but I always put one number in front of the decimal and the others after. Okay? Now, I'm going to multiply this times 10, and the power on the 10 is going to tell me whether I have to move the decimal to the left or move the decimal to the right to get back to my original number. To get back to my original number, the decimal needs to go to the left, so it's going to be a negative power of 10. And how many hops does it have to go to get there? Well, if I started my decimal here, I would have to go 1, 2, 3, 4 hops back to the left to get my original number back. So this is going to be times 10 to the negative 4th power. Okay, hopefully you understand scientific notation a little bit now. Let's try these 5 examples real fast and see if we can get them. Okay, let's do this quickly. So 265, I need to start that out by writing 2.65. Now, that's times 10 to the 1, 2 power, because the decimal moves to the right to get my original number back. This marker needs to be replaced. How about this one? This is going to be 7.2, oh yeah, times 10 to what kind of power? The original number, to make this go back to the original number, the decimal moves to the left, or the original number was less than 1. So this is going to be a negative power, and that would be 1, 2, 3 places. So that represents this. Okay, how about this one? This 0 is significant, so it's 2.80 times 10 to what power? To get the original number back, I'd have to go 1, 2, 3, 4, 5 places. So it's negative 5 because the decimal has to move to the left to get the original number back. How about this one? Are these 2 zeros significant, and is that 0 significant? The answer is yes, yes, and yes. So all of this whole thing is going to be part of my scientific notation, which in this case makes the scientific notation almost pointless, but we still show all of the significant figures, and that is helpful. So this is going to be times 10 to what power? To get the original number back, I'd have to go 1, 2, 3, 4, 5 places to the right, so that's positive 5 on the power of 10. Last one, 207,000, no decimal shown. So are these zeros significant? And is that 0 significant? No, these are not. Yes, that is. So 2.07, no other zeros are going to be used because they're insignificant, times 10 to what power? To get back to the original place, I'd have to move that decimal 1, 2, 3, 4, 5 places, so it's 5 is the exponent on the 10. Hopefully this helps you understand scientific notation a little better, and there will be some practice problems attached to the next slide for you to practice at home. Okay, here are 10 problems for you to practice at home, and these need to be worked out and shown in scientific notation. So I'll just put this here for you to look at, and I'll slide it up slowly, and you can copy the problems down, and or you can look at the screen and write down your answers and bring them to class. Okay, so hope you got all these, and we'll see how you did tomorrow.